Welcome to the deep dive, where we take a stack of information and really try to extract the most important nuggets just for you. Today, we're diving into the fascinating world of data visualization in R. Specifically, we're exploring the ggplot dotplot. Imagine you're, say, a data analyst at a bank, maybe, and you've got this data set full of customer credit scores. You need to understand how those scores are spread out, quickly and accurately.
Yeah, and it's a remarkably powerful tool for exactly that scenario.
Yeah.
Often overlooked, I think. But let's just see the granular story hidden in our data. We'll be drawing insights from an excellent source today, an article from RStudio Data Lab. It's titled ggplot.plot using rgm.plot, not plot using gplot2.
Okay, great. So our mission today is to unpack what a dot plot really is, why it's such a game changer for understanding data distribution, and crucially, how you can master its customization to reveal those maybe surprising patterns. Get ready to transform your understanding of how individual data points can speak volumes. So, okay, we're talking about the ggplot dot plot. What exactly is it, and why should you, our listener, really care about adding this to your data viz toolkit?
Well, at its core, a ggplot.plot, which you create using the gplot2 package in R, it represents individual data points as dots. Simple as that, really. But unlike, say, a bar chart or even a histogram, which aggregate data into larger bins.
Right, they group things together.
Exactly. The gm.plot function stacks these individual dots. And that clearly shows the distribution of a continuous variable. What's fascinating here, I think, is that it allows you to visualize the frequency and the spread of individual observations. So it's invaluable for small to moderate-sized data sets. It's really about honest and transparent data visualization. You don't lose sight of those unique data points.
That transparency, yeah, that sounds incredibly powerful. But if other charts might be missing these true stories, what specifically makes the dot plot uniquely capable of revealing them?
That really is the core differentiator. You're seeing every single data point, not just some aggregate or an average. So imagine you're looking at those bank customer credit scores again. A traditional histogram might just show a peak somewhere in the middle.
Yeah, like a general shape.
But a dot plot could immediately reveal, maybe, two distinct groups of customers. One with consistently high scores, and maybe another smaller group clustered around a surprisingly low score. Those kinds of isolated details, they often get completely obscured in aggregated views.
Okay, I see.
And the source highlights some key benefits here. You can spot these true stories. You can create your first plot in literally seconds.
Really, seconds?
Yeah, the basic command is simple. You can customize it to stand out, easily compare groups, and even add context with layers like a transparent box plot over the top.
Okay. So how do we actually get started with this in R then? To pull those initial insights from our, say, credit score data.
Right. Building your first one might sound a bit intimidating, but honestly, it's remarkably straightforward. The crucial first step, always, is loading the necessary R packages.
Right, the libraries.
Exactly. ggplot2 for the visualization itself, and usually dplyr for data handling. Think of it as, prepping your analytical environment. Once they're loaded, the process has two main parts. First, the gplot function, that sets the foundation. It defines your data frame, and crucially, the aesthetic mapping using EGs.
Okay, wait. What exactly is an aesthetic mapping? Can you break that down a bit?
Sure, yeah. Think of aesthetics as just visual properties, things like position on an axis or color or size or shape.
Okay.
And mapping is simply telling dplot which data variable should control that particular visual property.
I get it.
So EGXX, credit score, literally maps your credit score variable to the position on the x-axis.
Makes sense.
Then you just add the gm.plot layer using a plus sign that tells gplot, okay, represent this data as dots. This whole layered approach is what gives ggplot2 its incredible flexibility.
Right.
So to visualize those customer credit scores, you'd specify your data, map credit score to X and A's, then just add plus gm.plot. The exact syntax, of course, is detailed in our source article, but the power lies in how few lines of code it really takes to get going.
Okay, so once we have our data shown as dots, the next really crucial step seems to be making sure they stack up in a way that truly reflects the underlying distribution, right? How do we control that visual stacking?
Yeah, good question. Precise control over that. There's an argument called bind axis that tells ggplot which axis to use for grouping the dots. It defaults to the x-axis, which is usually what you want.
Okay.
More importantly, maybe, is stack dir. That controls the direction of the stack. You can choose up, down, center, or center hole.
Center, how does that look?
Using center, for instance, often creates a more balanced-looking plot. The stack grows outwards from the center line of the bin. And you can customize the fill color of the dots right inside this layer too, like fill a steel blue or something.
Gotcha.
The source provides full code examples for all these little tweaks. They don't need to memorize the syntax right now. Just understand the power these parameters give you.
Right. And the real power of ggplot2, as many know, comes from all those customization options. It's how you go from just a basic plot to something really insightful, yeah, something that highlights the story. How do we start fine-tuning the look and feel, maybe revealing even deeper patterns in our credit score data?
Okay, so customizing really begins with understanding binning, which is how gm.plot actually aggregates individual points into those visible stacks.
Binning, right.
It's essentially creating these virtual intervals or buckets
Huh.
along your x-axis, and each dot falls into its respective interval. The bin width argument controls the size of these buckets.
Okay, so bin width is like the zoom lens.
That's a great analogy, yeah. A tiny bin width, say 1, lets you peer into really specific pockets. Maybe you uncover a micro-cluster of credit scores right at 725.
Ah, something a wider bin would just smooth over.
Exactly. Conversely, a larger bin width gives you that wide-angle shot, essential for quickly grasping the overall shape without getting lost in every single point. The source advises, trying different values. See what tells your data story best without misleading. It's a bit like Goldilocks, finding the one that's just right.
Huh, yeah, okay. So once we have our bin width set, what does this mean for how the dots themselves look? Can we change those?
Oh, absolutely. You can adjust the dot appearance quite significantly. There's dot size that controls the diameter of the dots relative to the bin width.
Relative to the bin width.
Yeah, so a default dot size of 1 means the dots just touch each other side to side within their stack. Reducing it, say, to 0.5 or 0.6 adds some white space between them. Can make dense plots much clearer, helps prevent overplotting.
Okay, that's useful.
And you can also control the inner color with fill, like we mentioned, and add a border using color. Makes the dots look sharper, more distinct.
And you mentioned how they're packed vertically within each stack.
Right, there's stack ratio that adjusts the vertical distance between stacked dots.
Mm.
A value less than 1, like 0.8, adds a bit of vertical space between them. Can be useful if the stacks are getting really tall and dense.
Interesting. Okay. Now, building on that, a common challenge must come up when we want to compare different groups within the same plot, right?
Definitely.
Comparing groups side by side seems like where the dot plot could truly shine for our bank's customer data. Maybe seeing differences between, I don't know, male and female credit scores or different account types. How do we set up those comparative visualizations?
It's actually remarkably straightforward. That's one of the beauties of ggplot's grammar. You just map a categorical variable like gender or maybe policy type to an aesthetic property. Usually fill is a good choice for this.
Inside the A's. Call again.
Exactly, inside A's. So you'd have an ASEX credit score, fill these gender. ggplot2 then automatically assigns a different color to each group, each gender in this case,
Yeah.
and it creates a legend for you. Instantly transforms it into a comparative chart.
Wow. Okay. That sounds easy enough. But how do we make sure those comparisons are, well, fair and accurate? Like, if one group is much larger than another, won't their dots kind of dominate the visual?
That's a really great question, and it highlights the importance of another argument. Bin positions ill all.
Bin positions all. What does that do?
It tells gplot to calculate the bin positions based on the entire data set, not calculating them separately for each group.
Ah,
This is actually crucial for an accurate visual comparison. It ensures that a dot sitting at, say, 700 on the x-axis represents the same value for every group, regardless of how many people are in that group.
Yeah.
It keeps the bins aligned across groups.
okay, that makes a lot of sense. That prevents visual distortion.
Precisely. And you can see this in action particularly well when you use faceting. Yeah, using something like plus face wrap, marital status.
Mhm.
Faceting creates separate, smaller subplots for each category within a variable. So you'd get a separate dot plot for single, married, divorced, etc., all lined up. It allows you to compare distributions across groups in a really organized and clear way, still using that common binning.
Nice. And what if we want to avoid overlap when comparing groups, but maybe within the same plot? Not using facets, say comparing credit scores across different education levels without needing separate subplots.
For that scenario, position dodge is your friend.
Dodge, like move out of the way.
Exactly. This function cleverly dodges or shifts the elements. In this case, the dot stacks for each group, side by side, so they don't overlap. It creates distinct, readable dot plots for each group, but they share the same x-axis scale.
Okay.
The source actually demonstrates this, beautifully separating male and female credit scores by education level on a single plot. They use position dodge.
Yeah.
The point 8 controls how much dodging happens. Really effective.
Very cool. Okay, so seeing the individual dots is powerful. But sometimes we need to add some statistical context, right? Like a quick glance at the median credit score for a group or the overall range. How can we layer summary stats onto our dot plots?
Yeah, that's a common need. And a classic technique is to overlay box plots.
Box plots on top of dot plots.
Yep, you simply add plus geom_box_plot to your gplot call. The key is often to make it semi-transparent, using alpha 0.5 or something similar.
Ah, so you can still see the dots underneath.
Exactly. Alpha just controls the opacity, so you get the best of both worlds. The detail of the individual points from the dot plot, plus the summary statistics, median, quartiles, range from the box plot.
That sounds really useful.
It is. And you can also add specific points for, say, the mean or the median using stat summary. That function lets you calculate a summary statistic and then plot it as a point, maybe a big red diamond for the mean or something.
Okay, lots of options there. Now, what about just pure readability? Sometimes those x-axis labels get really squished, especially if you have lots of categories or long names. Any tricks for that?
Oh, absolutely. A really simple but effective one, just add plus chord flip to the end of your ggplot code.
Chord flip, what does that do?
It just swaps the x and y axis, turns your vertical plot horizontal.
Ah, so the long labels are now on the vertical axis where they have more space.
Precisely. It
Yeah.
makes labels much easier to read and often makes the whole chart feel more balanced, especially with categorical data that was originally on the x-axis.
That chord flip trick sounds incredibly useful.
Yeah,
Yeah, especially for those plots with many categories, maybe like different types of loans or something. It really transforms readability.
absolutely. It's
Yeah.
just one line of code, but the impact on the chart's aesthetics and readability, especially with categorical stuff, can be immense.
Yeah.
It can turn a cluttered, unreadable plot into something instantly understandable. And, similarly, knowing when a dot plot might not be the perfect fit and what alternatives exist, that's just as powerful a skill, isn't it?
True. When would it not be the best choice?
Well, while dot plots are fantastic for small to medium data sets, as we said, really large data sets can suffer badly from overplotting. Just too many dots piled on top of each other.
Okay, it just looks like solid bars then.
Pretty much, yeah. You lose the individual detail. Solutions include adding transparency with that alpha argument we mentioned, or sometimes switching to geom jitter.
Jitter!
Yeah, geom jitter also plots individual points, but it adds a tiny bit of random noise, usually horizontally and vertically, to spread overlapping points out. Helps you see density better when points are identical or very close.
So when would you advise choosing GM jitter over a dot plot? Or maybe something else entirely, like a violin plot?
Good question. A jitter plot, like I said, shows individual points, but it's generally better for somewhat larger data sets than a dot plot because that random noise helps spread things out and prevent that dense overlap. A violin plot, on the other hand, is quite different. It shows the overall density shape like a smooth histogram mirrored on both sides. It's ideal when the individual points are less important than understanding the overall distribution's shape and where the data is concentrated.
Got it. So different tools for different levels of detail and dataset size.
Exactly. If we connect this to the bigger picture, knowing when to use a dot plot versus a jitter plot or a violin plot, that's really a key skill in any data analyst's toolkit.
And for that final polish, making sure the plot communicates effectively.
Right, the final touches. Customizing labels, titles, and the legend using the labs function is absolutely crucial, especially for anything going beyond your own screen, like a report or presentation.
What can you control there?
Pretty much everything text-based. You can set the main title, a subtitle, a caption, often used for data sources, the X and Y axis labels, and even the title for the legend. It kills gender type instead of just gender, for example.
Okay.
This is probably the most critical step, honestly, in ensuring your data story is understood correctly, whether it's for that internal presentation at the bank or maybe a report for shareholders. Clarity is key.
Absolutely. We've really transformed our understanding of those credit scores with this dot plot idea, seeing individual points, uncovering hidden clusters. But is this visualization the final destination, or is it more like a crucial pit stop on a much larger data analysis journey?
That's an excellent way to put it, a crucial pit stop. Well, a beautifully crafted G-plot dot plot or any good visualization offers immense insights, it's truly just one piece of a comprehensive data analysis workflow. Our source, our Studio Data Lab, really emphasizes this integration in the solutions they offer. For example, a dot plot might reveal a potential outlier.
Right, that weird low cluster of credit scores we imagined.
Exactly. And seeing that might prompt you to go back to your data pre-processing stage for a deeper investigation. Is it a data entry error? Is it a real phenomenon? You need to clean that messy data, potentially.
So building these robust visualizations like our dot plot is really only possible or meaningful when you have rock solid, trustworthy data to begin with.
Absolutely. I mean, a beautiful dot plot built on messy or incorrect data is just, well, it's a beautiful lie, isn't it?
Ah, good point.
That's why those upstream steps like data preprocessing, which includes cleaning, handling missing values, outlier detection, are just so fundamental. Once you have that solid foundation, then visualization truly shines. It lets you quickly spot patterns that might inform your descriptive analysis or even guide your feature selection for something like predictive modeling, where you're trying to forecast future outcomes.
Okay, that really puts the dot plot's power into clear context. It's not just an endpoint, it's a window into the data that can guide your entire analytical process, from identifying issues right through to informing complex models.
Exactly. And the source makes a point of mentioning they use various industry-leading software, our Studio, of course, but also SPSS, Minitab, even Excel sometimes, to help turn complex data into clear, valuable insights. The goal is always to help you make better decisions faster. It just highlights that strong visualization is just one, albeit very powerful, piece of that comprehensive data journey.
Okay. Well, we've certainly journeyed far today. From understanding the basic anatomy of the gm.plot function in R, all the way to mastering its customization, comparing multiple groups, enhancing with stats. We've also tackled some common challenges and seen how this really powerful tool fits into the broader world of data analysis.
Yeah, it's been a good dive. My final piece of advice maybe is this: the perfect plot. It's rarely made on the first attempt. Don't expect it to be. The best data visualization often comes from iterating, from trying different settings, different bin widths, different aesthetics, and really seeing what tells the most honest and compelling story about your specific data.
So experimentation is key.
Absolutely. Keep exploring, stay curious, and let every single dot tell its part of the story.